Well, welcome back. Up until now, we've been talking about different ways of measuring binary outcomes. Now I'd like to talk about one special type of a binary outcome, a prevalence. A prevalence is measuring how much outcome, how much disease exists in a population at a point in time. And that's the point I want to stress. It's a snapshot. It's looking at people, taking a survey of them, asking them a question about their health, and reporting how much disease, how much outcome exists in that population at that one point in time. Well, up until now, we've been talking about measuring binary outcomes, so you have two options for measuring prevalence. You can measure what we call prevalence, and the word itself implies measuring a proportion. It's the proportion of people who have the disease at that point in time. It's the number of people with the disease divided by the number of people you're examined. So if I had a camera and could see each of you today, and I was looking to see how many of you were wearing eyeglasses, and I wanted to report the prevalence of eye problems among people taking this course. If there were 100 people watching me right now, and 30 of you were wearing eyeglasses, then 30 divided by 100, 30% would be the prevalence of wearing eyeglasses, the prevalence of having eye conditions. Alternatively, I could turn that prevalence into an odds. I could report the prevalence odds by taking the prevalence, 30%, dividing by 1 minus the prevalence, 70%, and the odds of wearing eyeglasses then would be 30% divided by 70%. Fairly simple. Okay? So, let me give you an example of some prevalence data. This is your Framingham Heart Study data set. What I've done is I've divided people into two groups, being a female or being a male. And further, I divided each group by their age into 4 age categories. People who are 30 to 40 years old, 41 to 50, 51 to 60, and above 60 for both the females and the males. What I have in the next column is the number of people who were examined at that 1956 exam. So, for example, there were 415 females in that 1956 exam who were between the ages of 30 to 40 years old. The next column tells me the number of people with pre-existing coronary heart disease at that examination. They had developed it in previous time, maybe the day before the exam, maybe a year before, maybe 10 years before. I don't know. All I do know is when they came to the 1956 exam and when they were asked, has anyone told you that you have coronary heart disease, a grand total of none of them said that they did. So the prevalence of having coronary heart disease among the youngest women in the 1956 exam would be 0 divided by 415, or 0%. But if I move to the next age category, there were 908 different women whose ages were between 41 and 50. 6 of them had pre-existing coronary heart disease at the 1956 exam. What's the prevalence of coronary heart disease among those women at the 1956 exam? It would be 6 divided by 908, or 1%. Now here's where the fun begins. Let's look at this last column of prevalence. We have the prevalence of coronary heart disease among women at 4 different age groups, prevalence of coronary heart disease among men at 4 different age groups. Let's look for associations. Let's look for trends. And not surprising, you'll say that among the women, the prevalence of coronary heart disease increases from 0 to 1%, from 1% to 5%, from 5% to 7%, as you move from one age group to an older age group. Prevalence of coronary heart disease increases. That might not be surprising to you. Same trend is seen among the men. The prevalence rate goes from 2% to 3% to 6% to 20% as you move among men with older age groups. Also, notice, fix any one age group and compare the prevalence of coronary heart disease among men to that among women, and you'll see that for any age group, the prevalence of heart disease among the men is higher than the women. So, for example, among the people who are older than 60 years of age, among women, 7% of them have coronary heart disease, but among men, 20% of them have coronary heart disease. much higher for men than women. The same result is seen for any other age group. That's the curse of being an epidemiologist. We look at data, and we start looking for associations. And we find that in this case, there are two types of association. The older you are, the higher your prevalence. The other one is showing that if you are a male, you're a higher prevalence than if you're a female. Now, what I ask you to do is think about possible explanations. This is the curse of being an epidemiologist. We see associations, and then we try to rationalize the reason, the explanation for that association. So let's see if you can act as epidemiologists now. Let's see what reasons you can come up with for why you see this general tendency for the higher prevalence of coronary heart disease existing for men compared to that of women. And the next time, I'll give you a list of at least a few possible explanations for that higher prevalence of heart disease among men and among women.